Hi everyone, this is Sanjeev Venkatram and welcome back to Business Insights. I'd like to spend the next 10 minutes talking about part 3 of applying the Microsoft platform to the manufacturing space. Note that this is especially applicable to the higher education vertical. In part 3 now and in this video, I'd like to highlight 3 key points. 1. The relative ease of setting up a real-time data streaming environment in Power BI from sensors. In this specific case, I'm using the SenseHat module from Raspberry Pi. 2. The ease of setting up experiments with near real-time data and visualizing results. For this, I use a temperature probe, the DS18B20, connected to the Raspberry Pi. And 3, the ease of using Microsoft Teams to collaborate across various functional groups as well as student communities. With this, let's get right into the demo, and I have 2 demos here to share with you. The first one streams real-time data from the SenseHat module to Power BI using Python code. To start with, let's look at the setup. We have the SenseHat module from Raspberry Pi. This module has many sensors, and we'll use the temperature, humidity, air pressure, and accelerometer sensors. We connect this module to the Raspberry Pi using onboard connectors. We then run an Ethernet cable from the Raspberry Pi to a PC so we can share the Wi-Fi from the PC. We power up the Raspberry Pi, and that's that from a hardware standpoint. From a software standpoint, the OS needs to be loaded onto Raspberry Pi. We then connect the device to the home or work Wi-Fi network. This does involve a few steps, and I have a couple slides in the appendix in the interest of time. With the basics out of the way, we then build code to talk to the sensors and stream data over to Power BI. So let's look at the code in Python. Note, I've included links to the code in the post. So we import the right modules and functions. As highlighted before, we're calling the temperature, humidity, pressure, and accelerometer sensors here. Now, in order for us to stream the data to Power BI, we use the REST API. As can be seen, we highlight the endpoint, which we can get from our Power BI service. We then stream the data to Power BI after formatting outputs to align with the setup in Power BI. Note, the rate at which data is streamed is controlled by the time.sleep function. Now on the Power BI side, we set up a new streaming service. This is an easy setup. We input the parameters we are streaming in and the units. We don't need historical info in this case, so we will keep this off. Do note that turning this on will not stream data real time, as the data has to be written into a table. So we get near real-time streaming if historical data is necessary. We'll talk through this in the second demo. Clicking on the API info gives us the link to the API that we then input in our code. Now we add a dashboard with respective tiles for sensor inputs. We have a few options here between line, column, and gate charts, and I've set this up using line charts. We run the code now, and as you can see, the sensor outputs are being streamed into the respective tiles. Any changes I make to the sensor environment is captured real time. As an example, putting a glass of ice close to the module. So in the net, fairly straightforward and simple to set up and run. We could also have sent the sensor data to Azure IoT or IoT Edge, and then to Event Hub, streaming, and Power BI. This is a fairly simple setup as well. Engineering teams in the manufacturing industry routinely stream data from modules, from engine controllers and body controllers as an example in the automotive industry. Also, vast quantities of data are collected from product testing, be it either in the prototype or production stages. So the use cases are many, and the setup that we've gone through, frankly, does not change much. The endpoints, be it either Power BI or applications, naturally will be different. So let's get to the second demo and actually do an experiment. We'll find out the heat capacity of copper, an experiment that engineering students do as part of their lab work. The hardware setup in this case is different. We take off the SenseHat module and connect a DS18B20 temperature probe to the Raspberry Pi. The probe has power, ground, and a data line. Note, we do need a 4.7K resistor. We make the connections using a breadboard. Note the wiring connections on the GPIO. We connect the data cable to pin 4. With this, let's look at the code. In this case, we need to bring the GPIO and therm libraries. We make sure that the right GPIO pin is highlighted to bring the data in. We also need to format the output in the right way, so do take note of this. The Power BI side is much the same as in the first demo, except we now turn on the historical data switch. Note, because we are capturing data in a table, the data stream is near real time and we do notice some latency. Now the good news here is that we connect to Power BI services from the desktop application and pull down the data stream. So let's look at the desktop app. As you can see, we have a live connection with the streaming service. On running the Python code, we get to see the data as we refresh the data set. Now on to the experiment. As mentioned in the prior video, we have set up Power BI in two sections. The one on the left is a manual, and the one on the right is the visualizer or designer. So let's look at the definitions. 1. Specific heat or heat capacity of an object is the amount of heat per unit mass required to raise the temperature of an object by 1 degree Celsius. The relationship between heat gained or lost and the temperature change is given by specific heat times mass times the change in temperature. We now get to the procedure and the steps have been detailed below. In the interest of time, I'll summarize. We'll heat a small copper block to 100 degrees C and put this in a cup with room temperature water. The hot copper cools and the water temperature rises. We know from the principle of conservation of energy that the heat lost by copper should be equal to the heat gained by water. We also know the specific heat of water. We use both these inputs to determine the heat capacity of copper. The key here is that from the stream data, we're able to pick up the key inputs to solve the problem. So let's see how. The chart here is the temperature output from the sensor captured over a period of 10 minutes. From this, we get two key inputs. The initial temperature of water, which in this case is the room temperature, and the final temperature once the hot copper cools, which is reflected by this horizontal line. From these inputs and using the right formulae discussed before, we find out the heat gain or loss and hence the specific heat of copper. To complete the process, I've added this Power BI report to Microsoft Teams, which is an outstanding tool for collaboration. Teams has different tabs such as File Share, Conversations, etc., and Power BI. So looking at Power BI, I see the exact same report we went through on the desktop. From this tab on Teams, I can chat with my fellow students or engineering groups, do video calls, and discuss and solve problems. A very effective way to communicate. I trust this gives you a view of how one can set up sensors and stream and store data directly into Power BI using APIs. Further, as to how one can design and perform experiments with ease. And finally, the ease of sharing information and collaborating with colleagues. Thank you very much. Please note that the views and opinions expressed in this video are mine and do not state or reflect those of Microsoft.